In this video, we're going to take a look at the summation of the square and cubes of the first n natural numbers. So these two results that we need throughout this video are given in the formula book, so that's quite nice. We don't have to worry about memorizing those results. So let's just start by giving these results here to begin with. So we've got sigma of r squared, so this is the natural numbers squared here, from r equals 1 up to n. Okay, and this result here is given as n over 6, or 1 over 6, times n plus 1 times 2n plus 1. Okay, so that's the first result that we need. So that's for the natural numbers squared. And then for the natural numbers cubed here, or for the first n natural numbers cubed, then it's going to be r cubed. And again, r equals 1 up to n there. Okay, and this result is given as n squared over 4, or a quarter, times n squared, times n plus 1, all squared. Okay, and again, that's the second result that we need, but we don't have to worry about memorizing these results. Like I said, they are given in the formula book. And again, I'm not going to show the derivation of these results in this video, but we'll save that for a separate video. Okay, but that's everything we need to get started. Let's take a look now at a couple of practice questions. So if we start with this question here, we're asked to show that this summation of 12r squared minus 2r plus 5 from r equals 1 to n is equal to this expression here. Okay, so where do we begin? There's quite a few different things going on here. So I need to understand how to break this up and make it easier to work with. And to do that, we're going to use linearity. So remember, we discussed linearity in the previous video. So if you're not too sure what linearity is, check the previous video and that will show how we break something like this down into something more manageable. So what I'm going to do here is take this bracket. I'm going to split this up into 3 individual summations. So what I've got here is a summation of 12r squared from r equals 1 to n. I've now got this minus 2r here, so that's going to be minus the summation of 2r from, again, r equals 1 to n. And then finally, we've got the summation of 5 here from r equals 1 to n. So a 5 here from r equals 1 to n. Okay. Now what I want to do here is use linearity again, because we're going to need 3 results here. I need the summation of r squared, I need the summation of r, and I need the summation of 1 here. So it'll make why when I show what happens now when we use linearity one more time here. So what I'm going to do now is factor out from each individual summation. I'm going to take this 12 out in front, I'm going to take this 2 out in front, and this 5 here, we can write that as 5 lots of 1 and take the 5 out in front. So what I'm going to get then is 12 lots of the summation here of r squared from r equals 1 to n. Now I'm going to take this 2 out in front, so that would be minus 2 lots of this summation. So minus 2 lots of this summation of r here from r equals 1 to n. And then finally again here, like I said, I'm going to write that as 5 lots of 1 and bring the 5 out in front. So that's 5 lots of the summation of 1 from r equals 1 to n there. Okay. So now, like I said, this is why we now need the results for the summation of r squared, the natural numbers squared, the summation of the natural numbers here, and then the summation of this term here of just 1. So in that case, the summation of r squared, we already know that, we just discussed that. So that's going to be summation of r squared from r equals 1 to n. That result is given as 1 over 6n, 1 over 6n times n plus 1 times 2n plus 1. Okay. So that's the summation of the first n natural numbers squared. We now need the summation of the first n natural numbers. So that's sigma r here from r equals 1 to n. In that case, we're going to get a half n. So half n times n plus 1. And then finally, for the summation of 1 here from r equals 1 to n, that's simply given as n. Okay. Now we need these 3 summations, so what I'm going to do is I'm just going to box these off here, just so we've got those in the corner, and we can easily take them as we need. So in that case then, if I've got 12 lots of the summation of r squared here from r equals 1 to n, and we know that that's equal to this result here, and I can just write that as 12 lots of 1 over 6n times n plus 1 times 2n plus 1. Okay, like so. Do the same here now for the summation of r from r equals 1 to n. Obviously, we just times that by minus 2, so I get minus 2 lots of this result here. So that's a half n times n plus 1, like so. And then finally, 5 lots of the summation of 1 here from r equals 1 to n. Well, we know that's equal to n. I get 5 lots of n, or just 5n there. Okay. So from here now, it's just a matter of simplifying and working towards this expression here, okay, on the right-hand side. So the first thing I'm going to do is multiply through by this 12 here with this bracket. So I'm going to get 12 over 6, which is 2. So I get 2n times n plus 1 times 2n plus 1. So n plus 1 times 2n plus 1. I've got this minus 2 here, so when I times through, I get minus 2 over 2n. But in that case, I just get minus n lots of n plus 1. And then finally, we've got this 5n here at the end. So plus 5n. Okay. So from here now, what I want to do is just keep simplifying. What I'm going to do in this case, seeing as we've got 4n cubed, 5n squared, and 6n, that would suggest to me that we need to expand everything. So I'm going to expand this double bracket here. So n plus 1 times 2n plus 1. So we're going to get 2n times, so I'm going to get 2n squared. I get 2n squared. I've then got n times 1, so that's n. And I've got 1 times 2n. So I've got n plus 2n giving me 3n. And then 1 times 1 giving me 1. Okay, so we get plus 1 there at the end. I've got this minus n now, so I expand this with this bracket. So I get minus n squared. And then minus n times 1 giving me minus n. Okay, we've still got the 5n here, don't forget that. So finally, if I expand through now by this 2n here with this bracket, what I get here then is 4n cubed. We get 4n cubed. 2n times 3n, so that's 6n squared. That's 6n squared. I've then got 2n times 1, so that's 2n. I've then got minus n squared, minus n, and then plus 5n. Okay, so at this point here, it's just a matter of simplifying the very last line, collect like terms. If I just do this in a different pen code just to show our solution here, then this is going to be equal to, I've got 4n cubed, and over n cubed terms, so I get 4n cubed. I've got 6n squared, I've got minus n squared, and then there's no over n squared term, so I just get 5n squared. So plus 5n squared. And then finally we've got 2n minus n, so that would just give me 1n or just n. And we've got plus 5n. So if I add those together, I get 6n there. So plus 6n. And there we have it, that's our solution as required. And there we have it, that gives our solution to the first practice question. So let's take a look at one more practice question here. This is a very kind of typical exam style question here. So let's take a look at what we've got. I've got the summation of r cubed minus 3r squared from r equals 1 to n. So again, where do we begin here? Because what I want to do is show that this is equal to this. Okay, now what makes this one a little bit more complicated than the last one is this quadratic here is including algebraic terms. I've got this an and this plus b. So we don't know what those are. So we don't know for definite at the very end whether we've got it quite right. But I will discuss at the very end how you can check your solution. So to begin with here, let's use linearity, and we're going to split this bracket up again here. So I can write that as two individual summations here. So I've got the summation of r cubed from r equals 1 to n. So that's the first part there dealt with. I then got this minus 3r squared. So how do we deal with that? Well, I can write that as minus the summation of 3r squared. Okay, from again, r equals 1 to n. Now what I want to do is use linearity one more time here and get rid of this 3 for this summation here. I want to put it in front. So I say I'm getting rid of it. I'm not getting rid of it. I'm just getting rid of it within the summation there. Okay, so obviously this doesn't change. So what I'm going to do is I'm just going to write this over on the right hand side here. So we've got sigma r cubed r equals 1 to n. So like I said, that doesn't change. But now I'm going to factor this 3 out here, and we can write that as minus 3 lots of the summation of r squared from r equals 1 to n. Okay. And now from here, this becomes a lot easier to work with because all we need is the results for the summation of r cubed and then the summation of r squared. So if we do that over here, so the summation of r cubed from r equals 1 to n, that result is given as 1 over 4, so 1 over 4n squared times n plus 1 all squared. Okay, and then for the summation of r squared here, so we're going to room a little bit, should just fit this on, and this is given as 1 over 6n times n plus 1 times 2n plus 1. Okay, now again, I'm going to box these off here. We do need those, so we just box those off in the top right corner. Like we did for the previous question, all I'm going to do now is simply replace my sigma r squared here, or r cubed even, with this result, and then I'm going to take this summation of r squared here, which is 1 over 6 times n plus 1 times 2n plus 1, and times that by minus 3. So what I'm going to get here then, if we do that down here, is I'm going to get 1 over 4, so 1 over 4 n squared times n plus 1 all squared, like so. And now we do minus 3 lots of this result here. So minus 3 lots of 1 over 6n times n plus 1 times 2n plus 1. Okay, like so. For now, I'm not going to do anything with this. I'm just going to work through by expanding this 1 over 6n times n plus 1 and this 2n plus 1 by this minus 3 here. So I'll leave that as it is. I get 1 over 4 n squared times n plus 1 all squared. Like I said, I'm going to multiply through now by this minus 3 here. That's going to give me minus a half, because obviously minus 3 over 6 is minus a half. We get minus a half n there times n plus 1 times 2n plus 1. Now what I do here is I just refer back to the required expression here. Because what I notice is rather than everything being kind of expanded, you know, involving n to the 4, for example, it looks to me like we've got a factorization going on here. Okay, I've got 1 over 4n times n plus 1 times this quadratic. So to me, this would suggest there's some factorization going on here. So what I'm going to do now is just look across my expression here and see what I can factorize. Now it's up to you whether you do this all in one kind of one step, or whether you do this step by step. I'm going to do this step by step just to hopefully break down the process. So to begin with here, what I'm going to do is I'm going to factor out an n plus 1. I've got n plus 1 squared here. I've got an n plus 1 here, so I can factor out at least n plus 1. Okay, so if I factor out n plus 1 here, we get n plus 1 in a bracket on the outside. And then if I put everything on inside on a square bracket like this, then I'm going to get 1 over 4 n squared. I'm going to get 1 over 4 n squared times that by another n plus 1, because we need n plus 1 all squared. That's n plus 1 there. We've then got this minus a half n times n plus 1 times 2n plus 1. Well, we've factored the n plus 1 out. I'm going to get minus a half n. Minus a half n. I'm going to times it by 2n plus 1. Okay, like so. I'm going to close my square bracket here. Okay. Now again, I'm going to keep working towards a factorization. What I can spot here straight away is we've got this n plus 1 on the outside. So it looks somewhat promising. I've got my n plus 1 here again on the outside. So what I'm going to do now is see what else I can factorize here. Well, when I look at this now, I've got at least an n here. I've got n squared. I've got an n there. So I can factor an n out. And what I'm also going to do is factor this 1 over 4 out as well, because that's a quarter. That's a half. So I can at least factor a quarter out here. So what I'll do is I'll do this in a different pen color here just to make it clear where I'm going. So hopefully I'll have just about enough room here. So like I said, I'm going to factor out a quarter n here as well. So I'm going to get 1 over 4n, 1 over 4n times n plus 1. And like I said, this looks promising now as well, because notice we've got the exact same here as our expression now. Okay, we're at the beginning of our expression. And in this case, once we factor this out, well, in that case, I need an n here, because I factored out at least 1 over 4n. We've got an n squared there, so I need an n. And we also have this n plus 1 left over, so that's n times n plus 1. Okay. And then I've also got this minus a half n times 2n plus 1 to deal with. So we factored out a quarter of n. So clearly I don't need an n there, but if I factored out a quarter, then this must be minus 2 inside the bracket. Okay, so that's going to be minus 2 lots of 2n plus 1 there. Okay. So that's my square bracket. Now notice they've got a quadratic here. Okay. Whereas on the outside, we've got the exact same expression, so I've got the same there as what they've got here. So that's good. And I need to just work on this square bracket here and hopefully obtain a quadratic. So what I'm going to do here now is expand both of these double brackets, oh sorry, not these double brackets, but expand these two brackets here, I should say, by the term on the outside. So I'm going to get a quarter of n times n plus 1. Now inside the square bracket, like I said, we're going to expand here. So I'm going to get n squared plus n, n squared plus n. So that's the first bracket there expanded. Minus now 4n, so minus 4n, and then minus 2 there. Okay. And at this point here now, we're pretty close actually. All I need to do now is just simplify everything inside this square bracket. Obviously, I'm going to get 1 over 4 n times n plus 1. But inside the square bracket now, we've got n minus 4n. That's going to give me minus 3n. So inside the square bracket, we get n squared minus 3n. And we've got this minus 2 here, and there's nothing else we can actually do with that now. So at this point here now, rather than writing this with square brackets, what I'll do is I'll write this with our regular brackets here. So get rid of that and that, and now I can write that with our usual brackets like so. And notice now I've got exactly what we needed to get here, a quarter n times n plus 1 times some quadratic. Now we needed to identify a and b here. So a and b are integers to be found, so they're just whole numbers. So in that case, a must be minus 3. So a is minus 3, and b is equal to minus 2 there. Okay, and there we have it. So that's our solution here at the very end. Highlight that there. Okay, and there we have it. So that's our solution. Like you can see, there's a lot of work and a lot of algebra going on with these types of questions, but that's a very typical exam style question. So make sure you are familiar with these types of questions. But there we have it. So that's our solution, and that brings us to the end of this video. So in the next video, what we're going to take a look at is exam revision for series and summation.